And good morning, world. Okay, right now, Gavin is over behind me setting stuff up. But first, it's time for me to say good morning. And before I get to that, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. I believe I have Castnote up and running, so we have TTS. Someone can do a say thingy and we will figure it out. So good morning to Tinker, Grant Mazels, Crispian is here, Stephen George, John Whips, Simon CBR, Russell Rainey, Imi is here, Any Mules, Vic Oliver is here, Andrew Ruthven, good morning to everybody, and anybody else who jumps into the chat. We will get to Gavin's project in a little bit.
Woot.
It's woot. Okay, I just need to turn the volume up. It's working, just not as loud as it should be. Gavin is setting up for showing what he's done on his project, but there is another little bit of embarrassment that I need to reveal first, and that is in relation to this. So, Beetlebot, we did the assembly, and then there was a problem. I plugged it in, it didn't enumerate, and so this was 2 streams ago, I can't remember, whenever it was, and I ended up sticking it on the bench and trying to figure out what was going on with it, and the problem was entirely my screw up. So I'll show you if I can get to it. Where is it? Here. I'll show you what I did wrong. Where are we? Sheets. I want sheets. Move it over to here. And if we come to the primary MCU, look at this. Where are we? Where are we? Here we go. Look at this. Primary MCU. So this is the ESP32S3, which is mounted on the chassis. It's the module that is on the PCB. We've got the USB connection here, D plus, D minus. Here we have DP0, DM0. So data plus, data minus, port 0. I wonder if anybody sees where this is going already. You might. Look over here. On the downstream side of the USB hub, we have DP1, DP2, DP3. Where is DP0, you might ask? DP0 is over here.
John has been kicking himself.
I have, yes. DP0 right here. So what I did was I effectively have the USB socket coming in here, coming to these 2 traces, these 2 signals, DP0 and DM0, which then branch and go to 2 places. They go to the USB interface on the S3 and to the upstream USB port on the hub, because I can't count past 0, apparently. That is what's going on here. So that is why, when it was plugged in, it did not enumerate. And in fact, there's a bit of a giveaway here. If you look at the net labels on DP2, DP3, you can see they have grid references. DP2 is going to sheet 2, reference 2A. It's like map references. This is sheet 2, grid reference 6C. So this one has none. These traces go nowhere. So the good thing about that was that it is a super easy fix. It's actually really easy to fix on that.
001 said, just so you know, John, USB don't work that way. Just saying.
Yeah, thanks. This is a lesson that I've hard learned. Now, if I switch over to the overhead camera,
so you've created isolation by design, did you? Well done.
No, I had a lack of isolation. So on here, you can see these yellow wires. This is bridging. So what I had was the USB connection coming out from the back of this module, and there are 2 traces that went up, and they joined onto port 0, which then also connected to the USB socket. So all I did was I cut those 2 tracks, and then I jump it across from the tracks that I scraped off up to port 1, and now it works. I plug it in, the device enumerates. In fact, I can.
No project is complete without bodge wires.
Yeah, it needs bodge wires.
Hi Gavin, it is all your fault.
Yes, it is. Correct.
So if I plug in power, you can see that it powers up, and you can also see that the LEDs are now doing things.
You can see
because
things.
they are being driven by the S3. Yeah, so on Monday night, I took this along to the MLAI meeting, which Andy also attended, and afterwards we went to dinner, and sitting in the little pub restaurant thingy where we had dinner, Andy pulled out his laptop, plugged into this, and was beavering away with it and installed
At
MicroPython.
Vigoliver said, all good prototypes need spaghetti.
Definitely, lots of good carbohydrates. So he plugged this into his laptop, got MicroPython installed on it. So MicroPython right now is running on this S3, and then he wrote a little bit of Python, which drives the RGB LEDs. And because of the color response of the camera that you are looking at it with, it kind of just looks white, almost white, a little bit touch of a blue. You can't see the distinction in the colors. They're actually cycling through different colors, like going pink, like that one just went pink, and now they're blue. So they're doing fadey effects. It just doesn't show up very well on camera.
They don't believe you, John, but
No,
I
they
will
don't.
confirm
Okay,
you.
I have an independent witness here.
Independent witness,
Mhm.
yep.
Thank
Willing
you.
to sign a paper.
Yep, I'll need you to sign the affidavit after this. So, yeah, so that's the result, is that we now have this in a state where we can run code on it, and I need to finish the mechanical assembly, so bolt the motors on, connect the H bridges, and I also need to put the ESP32 cam in here, and then get it back to Andy so that he can do his software magic on it and make it do useful things. Because in my hands, it's just a bit of copper and fiberglass and some odds and ends. It needs the software on it to actually be useful. So, next, because having learned that, I then went to this, where are we, Beetlebot. I've done this one, so I have actually fixed it. And there was one other thing I fixed as well. What was it? Oh, that's right, I remapped some things to the risers. I'm going to close these once Fusion figures itself out. Close those and close that. Yeah, I remapped some I/O for the risers because I realized that I overlooked something. I missed an opportunity, which was this. So firstly, you'll see that this is now D1P and D1N. Oh, and also you'll see that the designation has changed. So instead of previously this was called DP0 and DM0. It's now D1_P, D1_N. And that is because I went to the trouble of actually rerouting all of those differential pairs with length matching. So I rerouted all of the, if we come up to, well, down to here. So you can see that the traces have been renamed. They're now _P_N in each case. And what that does, by using this designation, it allows Fusion to recognize that these are matched pairs and they need to be routed as such. So back over here, if we come into here and rip up all the copper pores, there are a couple of places where there are little jiggery jakes. Like you can see here, for example, the USB-P, USB-N, it's got these little jiggers in it, and coming along here somewhere there's another little thing here, and and yeah, and stuff. Anyway, that is in different places. This one as well, you can see there's a little in it there. That is just part of the length matching. And there. So what I did was I ripped up all of the USB tracks, and then I rerouted them using differential pair matching. I didn't actually need to, but I did it because I could. So now we have a V1.1. In fact, if I flip that, you'll see this looking at the bottom of the board. So we've got V1.1 Beetlebart, and it now has the USB connections fixed up. So the other thing that I fixed was, if we come back to here, I missed the opportunity to be able to add more RGB LEDs to the existing chain. So at the moment we've got IO0 here driving a level shifter, going into the two RGB LEDs, which are like the headlights or the eyes on the front of the robot. And previously, the data output from the second LED went nowhere. So what I've done is added a net coming out of that LED. So we've got RGB LED now. And if we look at the top plate risers, we now have RGB LED right there. So the end of the LED chain now goes up one of the risers, so that you can continue adding RGB LEDs on the top plate of the robot, and it'll all just be driven off the same I/O pin. It'll be part of the same LED chain as the two LEDs on the bottom. To do that, I had to sacrifice an I/O pin, but I think it's a reasonable compromise. The other way to do it would have been to just leave the in fact, I did actually kind of go backwards and forwards on this a little bit. Because the other way of looking at this is, if I had left it as one of the other GPIOs, what you could do is run two chains of RGB LEDs and have the primary chain, or the chain on IO0, being the two that are on the front of the bot, and then you just arbitrarily designate one of these other IO pins as being another RGB LED data line, and then you could have it as two different sets of LEDs. So that would have been the alternative way to do it, but I decided, for the sake of clarity, it's actually applying a constraint, but it becomes a little clearer, I think, to bring RGB LED up to the top plate. So the LEDs on the top plate will be a continuation of the string from the bottom plate. What else did I do? I think I changed a couple of pins. Oh no, that's right, I rerouted the port 3 data with differential routing on that. In order to do that, I freed up another I/O pin, but I honestly can't exactly remember what I did. So it was, yeah, one of those cases where once the pin allocations on these risers are set, they should not change, because I do not want to break backward compatibility once these bots end up in the hands of other people. I want it to be consistent. Oh, that's right. Oh, there was one other thing. Yes. Okay, I will get to that. Yes. So there were three changes. The third change was important. I will get to it. The point was, I do not want these to end up out in the world and then decide that I needed to add signals or change signals that are on these risers, because it'll break compatibility with things that people have already done. So I want to be pretty confident, and if I'm going to change this, I need to bite the bullet and do it early on. So just make the change right away, and then I'm going to live with the consequences indefinitely. So changing that pin to being the LED pin and having IO9 opposite that works out nicely. Okay, so the associated change. Oh, a couple more people are in the chat, including good morning to Princess Fiona. Mark Laguda, Stephen44799, Don S is here from New Zealand. Good morning, everybody. Yeah, so the third change was this bit down here. This is new. So we've got from the ESP32 cam, IO15 and 14, TX and RX respectively, linking through to RX and TX pins 10 and 11 on the S3. So pin 10 and 11. So this is partly where I gained back a pin from this. So this connection here, where I've got RGB LED, that was originally, I think, IO10, maybe? I can't remember. But in any case, what I have now, this was a big oversight on my part when I was doing the original routing on this. I was not working from a nice organized checklist or anything, which I should have been. I was just seat of my pantsing it. And I totally overlooked that Andy, early on in this project, said that we needed to link the S3 and the ESP32 cam by serial, because in my head I thought they were totally independent. I thought that what was happening was that the ESP32 cam would be receiving power from the main board, but would be using Wi-Fi to stream its video to the remote system, so that the video could be processed by the pipeline, decisions made using the VLA, and then commands sent back to the S3, also via Wi-Fi, and that is how the motion would happen. But the ESP32 cam and the motion control were totally independent systems that didn't need to talk to each other, because the communication would go through the pipeline. So that is the architecture that I had in my head, and I just did not remember that Andy had said we needed to connect the two processors directly so they could talk to each other. So I fixed it. So we've got now 10 and 11 being a serial port. So this can be a UART coming off the S3. And the reason I've got these little cut track jumpers on here is just for net name matching, because it is, hang on, that I just clicked the wrong button. Quit, get out of that. I was trying to click that button. That. So the reason is matching up TX and RX. And if you just run a single net to directly link between these two processes, it could be really confusing, depending on how you designate these nets. And a very simple way to do it, one way that I often do it, is actually to use a bridging resistor. You could put something like a 1K resistor between the two. So you have the TX line coming out of one UART, and then it goes through a resistor, and then it goes to the RX line of the other UART. That resistor can be useful in terms of providing a little bit of protection. For example, if both ends of the chain try actively driving that pin in opposite directions, that can be bad. So you can effectively be driving into a dead short. So you could have, imagine you screwed up in your firmware and you have a direct connection between two I/O pins on two microcontrollers, and in the firmware on one microcontroller you drive it high, and in the firmware on the other microcontroller you drive it low. You now have effectively a dead short between positive and ground through the MOSFETs in the microcontrollers that are trying to drive those lines with no current limiting whatsoever, and that can do really bad things. So having something like if you have two I/O pins connected directly together, having something in the region of a 1K resistor between them gives you protection, because the 1K resistor, according to Ohm's law, in fact let's look it up. Ohm's law calculator. This is the one that I typically use just because I'm lazy. Let's say we've got 3.3 volts and we have 1,000 ohms. Let's see what we're getting. Amperes. So 3.3 milliamps. So basically it is, yeah, classic. That's one I should have done in my head. Problem is when I do this sort of thing in my head.
001 said, can the S3 reset the especially cam?
That's a good question. I can't remember. I don't know. Yeah, I can't remember. Let's have a look at that in a second. So whenever these sorts of things come up, I am notorious for getting stuff off by orders of magnitude. So I never trust my own brain doing these calculations. I always have a calculator sitting right here next to me under my left hand. I have the trackpad on my left hand, the calculator is right next to it. Even if there are really obvious calculations, things that I think, yeah, I know the answer to that, I calculatorize it anyway, just as a sanity check, because otherwise I can end up in situations where my brain has misfired and I'm off by like an order of magnitude on something.
001 said, might be a good use for one of the leftover I/O pins on the S3.
Yeah, that's true. I think we're getting low on I/O pins. So we've got, so anyway, the point being, if you have two GPIOs that are connected together, it is a good practice to put something like a 1K resistor in between them, because you can still pass data through the 1K resistor. It will not it'll not very badly impede your ability to do serial data through it, but it will limit the current to 3.3
Are you out by an
milliamps.
order of magnitude? No worries. Become an astronomer.
Is that a common experience for astronomers, to be out by orders of magnitude? It possibly is. So, yeah, anyway, point being, doing that means even if the two pins are trying to drive that net in opposite directions, the maximum current that either of them will need to either deliver or like source or sink is 3.3 milliamps, which is within the capabilities of an I/O pin. So you could go lower, like you could put a 330 ohm resistor or 220 or something like that in there, and it would do the job just fine. It would protect your I/O pins. So yeah, that's one thing that I often do. However, okay, so this is an interesting little design decision. I actually considered putting resistors in here where these cut track jumpers are. That would have been my first preference, but I would have needed a new stencil. So one of the things that I have cunningly done with the changes that I've made here is I have not moved a single part or made any changes that would require the stencil to change, because I'm being cheap and I don't want to order another stencil just to add 2 resistor footprints to the board. So anyway, I use cut track jumpers instead. And the intention is that these cut track jumpers, they're tiny. So these are 0402 size cut track jumpers. The intention is they are never actually going to be cut. The only reason they exist in the schematic is to provide net name matching so that I can very clearly represent that the CAM's TX line...
001 said, for that matter, 0 ohm resistors make awesome removable jumpers.
Yes, that's right. Yes, so if you put down a footprint for a resistor, you can just make it a jumper. And it goes to the RX pin of the other side. So this is a way of making it very, very clear in my own brain that I am sending from TX to RX and I'm sending from TX to RX in the other direction. So, that is, anyway, that is why there are these little cut track jumpers here. Cam RX, Cam TX go through the cut track jumpers and come down to here and all the way around here and come to the S3 right here, TX and RX. Now, Tinker, you were talking about reset. Let's have a look, because I honestly can't remember. I know I've done that sort of thing before, but I just can't remember if I've done it here. So we've got Cam RST. No, actually, I do not have control of Cam RST.
Gavin makes a lot of weird noises.
Yeah, apologies.
Yeah, Gavin is mic'd up at the moment, so you're hearing from both of us.
You haven't heard the internal swearing that's going on in my head.
Yeah, the voice inside your head is staying inside your head.
I'm
for now.
keeping it well and truly placed there. Yep.
So the reset line to the ESP32 cam is coming off this jiggery pokery little circuit here with the dual opposing transistors running off the DTR and RTS lines from the USB to serial converter. And I actually still haven't tested this. So this CH340K, I am, just zoom in right here, so I am very interested to see how successful this CH340K is, because it may become my cheap go-to USB to serial converter.
Gavin, neural link.
Neuralink. No, you really don't want to know what's going on inside my head. There's two people fighting at the moment.
The two wolves are fighting.
That's it.
The one that wins is the one you feed.
That's right. No one becomes dog food.
Yeah. Yeah, so this CH340K is very interesting because it doesn't need an external oscillator. There's no crystal, there is nothing else, there is no configuration. It is not flexible in that it does exactly out of the box what it is only ever going to do, and you can't change it. So you can't change its vendor ID, its USB device ID, or anything like that. It is super generic.
Let it go. Let it go.
But in some situations that is actually a benefit. And in situations where I don't want to go to the trouble of using something like a CP2102N and then building a profile and then having to flash the configuration to the USB to serial converter before I can then even talk to anything else on the board, this is just a super cheap, simple way to achieve the end result. So what we've got is Cam RST being driven off this. I could link this to an I/O pin. Do I link it to an I/O pin?
At Tinker001 said, CH340 family chips are massively better than the CP family.
Ooh, that's a big call. CH340, I've had problems in the past with some CH340s. I've had some annoyances. One of the, but I haven't used the 340K. This is the very first time I have ever put this on a board. I've used the 340G and one other one, I can't remember what it was, and it had some issues. I can't even remember what. It was years ago. I actually put the 340G on one of the revisions of the air quality sensor, and then I switched. I went through 3 different USB to serial converters on that project. I think I started with a CP2104, and then I went to a CH340G, and then I went to a CP2102N, and I think part of the issue might have been with the 340G that it needed the crystal, and it was just a little bit annoying in some way.
I was about to ask you, John, if you're changing between the chips, are there major changes to the design to do that, or is it?
Not especially. It's just around this region.
Okay, are they pin compatible?
No,
no,
most definitely not.
Okay. Yep.
So the difference is around basically this block right here changes. This other part to the right of it doesn't. So if this was replaced with a CH340G, which is its big brother, it's got more signals and things coming out of it, more pins. It also needs an external crystal. So this would be replaced by a bigger chip plus a crystal hanging off it, and I think it's got a couple of other supporting parts as well.
Yeah, so this part, real estate, really.
Yeah. This part becomes a bit more complicated, but the signals that come out of it here end up being the same. So the 340K is one that really interests me because it has just, we don't care about CTS. That's an unnecessary
You're
signal.
just tying it down low.
But it's just being left floating in that case.
Yep.
But the signals that are on it are exactly the signals we need and nothing else. And it requires 0 external parts.
Yep.
No crystal, nothing else. You just plonk this cheap little thing down on the board and it does exactly what we want. And that's it. So yeah, I think the 340K is a really good option for a USB to serial converter for general sorts of projects. Oh, we've got a few more people in the chat. David Crisp.
Not in the cat.
Gil not in the cat. No. Keith H is here. Amanda is here. Wagon Loads, Jack's Tech. Welcome. Yeah, so. Okay.
Right.
Before I wrap this up, one little decision to be made. So we're going to have a look at Gavin's project in just a second.
No, you're good.
I guess that having two CH340K devices on the local hub might get confusing if you can't change their ID.
Yes, exactly. Although it can be confusing, you can differentiate between them based on their position in the tree. Meow. How many cats in the chat? Stinker. So what would happen is the two devices would come up with the same vendor ID and product ID. Was it VID and PID? Product. I think it's product ID. I can't remember. And so you would see two different devices that are essentially saying they are the same thing. But if you look at the USB device tree, you would see they're on different ports because they would be connected via the USB hub on different ports. And you can trace the device tree down and find the devices. And if they are wired on the same board through a USB hub, then they will be consistent in terms of which of the ports of the hub they appear on, because it's not just being plugged in and plugged out, it's literally wired on the PCB. It's traces on the PCB linking to the USB hub. But yes, that is one area where something like a 2102N is nicer, because you can create a different profile for the devices. And when you plug them in, your computer says, no, you can have UDEV rules on your computer or whatever your operating system uses to say something like, this vendor ID and product ID combo, I want you to map to this particular device or this driver, or identify it as this type of thing. So yeah, that's where the configurable devices start to become really useful. So the question to resolve before I send this off for fab is, do we want to link the ESP32 cam reset? I need to start paying attention to chat too. The only things I've been hearing are
You put it over there and I'll keep an eye on the chat.
Okay. I will zoom it in as well.
You know you need 7 screens, John. You've only got 5.
Yeah, I know. I am screen poor. If you use a 340X, you don't need 2 transistors to do ESP8266 programming. Oh, am I about to change
again?
Change again? 340X, yeah. The ones I trust are FTDI and 210X, says Wagon Loads. Yep. Everybody's got opinions about USB to serial converters, and people can be surprisingly passionate about it.
Andrew took his 14-year-old to the local uni for their open day on Friday, chatting with the head of space science major, and found out about a project for New Zealand school kids to put a PCB in a CubeSat. That sounds like something somebody else I know has done.
Yeah.
Something similar.
Something similar.
Yeah.
Sounds vaguely familiar. That's really cool, Andrew. Very nice. I hope your 14-year-old is inspired. So.
And a big meow from Jack's Tech. That's okay.
Yep. Now, where are we? S3. What I could do is, if there is an I/O pin spare on this, I could link that to ESP32 cam reset so that this could drive the reset pin. So I need to be a little careful about it.
And Amanda's packing up stuff today. She's moving apparently.
Oh.
I don't know what she did wrong, but they made her move.
Okay. Now, thinking through this, if I connect this, the reset line to...
Yeah, note cam reset and IO0 to the main ESP32 so you can flash it from the main processor, says Stephen.
Cam reset and IO0. Would I... Is there a situation where we need to push firmware to that from the S3? And we need 2 more I/O pins. I could use IO33 and 34.
Oh, I'm your new AI assistant apparently.
Yeah, thank you.
Yep.
Yeah.
Yeah, thanks Keith. Yeah, I only get several things wrong a day.
So I can't use 47 and 48 because I believe these are input only. I can't remember. There is something weird about IO 47 and 48 on the S3. Or maybe I'm thinking of 45, 46 because of the strapping pins. These ones I want to avoid because they are used for other purposes. We've got IO 43 and 44, TXD0, RxD0.
Yes, Jack Sec. Actually, maybe, I don't know. It depends on the day and the time, to be honest. But I won't apologise all the time, I must admit. Oh, sorry.
And most importantly, don't tell me that everything I've said is a great idea and that it's insightful and all of that sort of sycophantic stuff that AI does. Oh, it rubs me up the wrong way when that happens.
Just do it.
Yes. So,
and if anyone can figure out how to put caveman mode into Claude, I can do it on the console. I haven't figured out how to get Windows to do it yet. And that turns it into a you go do, I do, I done, finished. It's like one-line responses instead of 27,000 tokens.
that sounds fun.
Yeah, it's called Caveman. It's a GitHub-y thing. Caveman, yeah. Shut up and do the job. Get the club. Hit him.
Okay. So
Heck everything Jono says he's a great idea, etc.
yeah, Crispian is an AI. So I could use IO38. I can use... So IO33 and 34 are only on the mini version of the S3 module. They're not exposed on the full-size S3 Vroom. But that's not a problem because we're using the mini, so I can make use of those pins. So IO33 and 34 could be connected to cam reset and cam IO0.
And David Crisp, I think that's one of those "oh no, not again" moments, I think, from Hitchhiker's Guide. It's feeling that way. That's a totally horrifically stupid idea and it's going to fail horribly, and it generally does. Now, here we go. Stephen's got something.
Yes, 47 and 48.
Are regular I/O. 45 and 46 are strapping pins. 47 can be strap pin, but you have to burn the E-fuse for that to take the effect.
Okay. So 33, 34 are on 28, 29. I'm talking about physical pins. 47, 48 are on 27, 30. So they are all in a row. In terms of routing ease, where are pins 27? Where are they?
40,
it's
40,
up
47,
here.
48.
There we go. Oh, that's pretty nice, and there's lots of space around here too. So I could very easily
Is it 47
route.
or 27, John? That says 47, you're saying 27.
No, I'm talking about the physical pins.
Okay, just
so
checking.
IO, 47. So it's these pins here, 26, 27, 28, 29. Those are the physical pins that I would need to route to. And that actually works out really nicely because it just needs to be routed. It needs to be routed from those pins right there up to signals up here. It's a very short route. Even I can manage that. So I've got blockers on layers 2, 15 and 16. It's a 4-layer stack up, so I'm just saying 15 and 16 because of the way Eagle/Fusion does its designators. So from the top down, it is layers 1, 2, 15, 16, and all the numbers in the middle are missing. So I've got blockers there, so on layer 2, layer 3, layer 4, effectively. But I can route around that. There is so much space on this board. It is kind of overkill using a 4-layer board for this. It's a fairly straightforward routing job.
Yeah, we haven't seen Dr. Semiconductor making leads in his dirty DIY lab. Not dirty lab.
Oh, really? Did I see it? No.
No.
I have not seen Dr. Semiconductor making LEDs.
Kind of overkill when you can
Kind
buy
of
one
overkill.
from China for 1%. Yeah, probably.
Yeah. Probably.
Sounds
Okay.
like something.
Think about between the streams.
Oh,
Time for
Gavin.
Mr.
Oh, they're
Gavin.
pushing for the part B.
Yeah. All right. So,
Sounds like something to think about between steams. Time for Mr. Gavin.
Yeah. So what I'm going to do is make a to-do for myself here. And that is going to be link IO pins from S3 to control ESP32, cam IO 0 and reset. Yeah, so that'll be a little to-do for me another time when I get a chance. I'll stick that down here, and maybe I will make it huge, just so I can't miss it. There we go.
Oh yeah, you'll trip over that.
Yeah, I'll trip over it.
You'll definitely trip over that. No question. Yeah.
Yep. Okay.
Red, bold, double mark.
Yep.
Underscore.
So I'm not going to send this off for fab yet. I will do a few more cleanup things first.
Right, what's it say?
17 minutes before time for topic. Yeah, because I can't get onto the actual topic until an hour into the stream.
That's it. If you do, something's wrong.
Yeah.
Yeah, that's my observation, just
Yeah.
quietly.
So I think we should get into the topic.
We should. What was the topic? Because I don't remember.
I've got no idea.
I don't. I didn't even look.
No,
I didn't
no.
even look. I just came. I've been spending yesterday doing things,
Okay.
not necessarily good things.
No?
All right.
good things.
So, what have I made? Okay, John.
What have you made? All right.
What did we do last
Let me
time?
just get this reorganised. I'm going to switch to this camera.
That's okay. Where did we leave our hero last time?
Where we
Was
left
he-
it last time.
Dangling off a cliff with his explosive in his hand when he
yeah,
had to
waiting.
get out of the world?
That's right. Waiting for resolution. Same bat time, same bat place. Next episode.
Yeah. That's okay. So last time,
You are
was
slightly
Hendrik
off
in the
camera
house
there.
because I've got to know whether I've got to dance. That's the thing. Is Hendrik in the house?
I haven't seen him.
Okay,
you
right.
are hanging off the side of the camera.
I will
view
do
there.
that occasionally. Oh,
Yeah.
damn. Look at the hair's not good. The makeup's not good. No, it's all right. Okay, I'll be hanging off the edge of the cam. Thank you for letting me come on your podcast, John. Appreciate it.
No worries.
Oh, there I am over there. Right, where did we leave off last time? I had a fan, I believe, and we were trying to sense some stuff, weren't we?
Yes.
And we managed to get at the very end a Hall effect sensor with a piece of, what was it, blue tack, a motor, a Hall effect sensor, and we went over and got something working on the other side of the room near the air conditioner.
Yes.
And got rotation.
Yes, we were getting pulses coming off it, and
Yep.
we were reading the speed of rotation of the fan
Okay.
to give us approximate airflow.
I've got many fans apparently. I've got a few in my bag here, Keith. Yes. Okay. So I made a bit of progress since then. This is the kind of. Oh gosh, I got this screwed in. Can we show
Let's
people that?
yeah. Let's
That'll
switch
be-
to what we could do is switch to the overhead view,
Okay.
which is this one. Where is it? There. Okay.
Okay. So
I am
this
now
is,
off camera. This is now Gavin's show.
Yep. Oh no, that's okay. John can sit there and relax now. That's
Yeah.
okay. So basically, I think last time we put a Hall effect sensor on the top here, and we spun the blade. You've noticed this one doesn't have a blade because I broke the axle on this one.
Oh.
Which is very sad. But I did. This is the new model fan. The one. There's an old model fan, the new model fan. I bought new model fans. They don't have as good a
Oh, the bearing?
The bearing mount itself is not holding itself in place, so you can't easily hang it this way because it tends to drop
Oh,
in.
it'll fall out.
And if you put it this way, it's okay, and then on its side, it tends to want to walk out.
Right.
So it's got a few things going on there. I tried to solve the problem by putting something on this side to push against it. Of course, that creates friction.
Yes.
When we don't want friction. Well, we can tolerate friction in some environments, but not in others. Let's put it that way. Okay. So I'm going to be an Indian giver, John, and I'm going to have to borrow back the fan I gave you last time in order to get at least another fan that matches the one I've got working.
Okay.
Whilst I figure out how to fix this one.
Sure.
So there's a bit going on here in my head, as you can tell. The words are coming out now, which is good because they were stuck. They had nowhere to go. So this is the Mark 1, if you like. This is the where we left last time. Node MCU, a bit of code from Hendrik. Yep, and we got that going. Right, okay, so then, John, I posed myself a challenge and learnt a little bit about that KiCad program.
Heard of that?
Heard of that program. So I went and
I've heard
designed a
that I should be
PCB.
using it.
I don't know where we can show that one. Where is it? Down? Up.
Down there?
Yeah.
Yep.
So I don't know how we can get that. Yeah, that's okay. It doesn't matter. Designed a PCB, sent that away, paid the princely sum of $2 for the PCB, and $18 for shipping, and it was about here in about 4 days. So I don't know if that's normal.
That sounds pretty good.
And DHL Express or something, they said it was going to be a week and a half, and then suddenly the next morning it was on my doorstep. So I don't know how logistics work. I guess I've got to put a number on things.
That's magic.
So it's okay, right. Shout out to John Spencer, who's probably not in the cast at the moment, but he likes his tiny AT85s, if I remember rightly.
He does indeed.
He does love those, and he's always talking to me about how I should learn something about them. So I didn't really learn much about them. I learned a little bit. What I learned was that I learned something. Claude learned a lot. Okay, Claude was very helpful at this time around. I'll use this as a probe. So I've got here 2 headers, 4-pin headers for I2C. Is that the right word? Yeah, that's the right word. A position of mount of tiny, a little reset pin which is tied. I've got an extra output which I'm not currently using, and I've got a ISP. So
a programming header.
So I can put a programming header, so I don't have to keep taking the board out to reprogram it. I just have to disconnect the 2 connectors and plop it in there and just burn new firmware onto it. And then up here there's a little LED, a little light, and the Hall effect sensor, which we had last time, is now part of the PCB up here.
Nice.
Okay,
So that would mount over the centre of the fan, and then it puts the Hall sensor in the correct place.
Indeed it does. Now John does have a screwdriver around.
I have a
Meanwhile,
various screwdrivers.
in another life, we now have a much improved version. Now we need a bigger Phillips head screw. This might fit. I don't want to destroy anything. So one part.
If that's not big enough, there is also a bigger one.
No, it's
over to your right. That one looks okay.
Yeah, this one's fine. I just don't want to wreck your screwdrivers, to be honest. So this is the Mark, I don't know, Mark 17. Yes, you may notice the fan doesn't sit square on the holes at the front, which I designed. I made the box too small by a bit, but it didn't happen to fit. So it all squeezes in there, and I don't know if you can see that.
Yes. So it spins just by blowing through it.
Yep. Bit of oxygen going on there. And when we hook it up, the little LED flashes each time the Hall effect sensor goes past. Now, last time we had some blue tape or something, blue tack. I do have to come up with something here. Oops, a bit of stuff's there. A few screw bits coming out, John. Sorry about that. I'll clean that up later.
No worries.
So where was my brain cell there for a second? So now we've got a temperature and humidity and sensor in there on the I2C bus. We've got a tiny, over here, tiny 85 with this on the same bus. On the end of that, I know this is terrible, okay, butcher time. I needed to do it quickly, so I had This is just an old-fashioned telephone cord, you could say. I bought some new-fashioned ones from China.
Yeah, Stephen said that's an odd-looking telephone.
It is an odd-looking telephone. Yeah, I've got, so I bought, because I wanted to have maybe 2 or 3 inputs on this, one from the outside and one from, well, one side of the air conditioner and one from the other. So if you think about an external split system, you've got air pressure and you've got airflow rate and temperature and humidity going in, and it goes through the
Gubbins.
the bit at the back that either heats or cools when you're mounting it outside. And that's an odd-looking telephone. It is. No, mount that on your car roof, tell how fast I'm driving. I think I'd use the other blade, to be honest with you, because I think I'd kill this one. The other thing is I might actually, because if I haven't programmed the firmware correctly, I'm guessing, it will probably go saturate. It thinks it's their magnets there all the time if I go too fast. I'm not sure about that part at the moment. I haven't really done that. Today is the acid test, to be honest with you. Up until now, it's been this. Oh, it spins freely, or my finger, one of the two. That's all I've been using to drive it. So I did momentarily put it on yours outside just to see, and it does seem to spin nicely in both directions, freely, without a problem. So I needed to make a header because I was going to get some RJ12s and make it a modular system, which is possibly the long-term plan, so everything plugs in and unplugs. And they arrived from China yesterday morning or something, the other day, via Australia Post. That's a whole different story. So this should be modular so that something can be fixed and repaired if we need to. Okay, and that goes into there. So this is now part of an ecosystem because we love making ecosystems. Now I've come to borrow some red LEDs again from John for my other 3 spare PCBs. Where are we? Over here. I've got 1. You get 5, don't you? I give you 5. Typically 5. So there's 1, 2, 3, 4 you can account for. And because I didn't have a programmer, I'll just have to find the ribbon cable. I kind of used one.
Oh, to make a programmer.
To make a programmer. So where are we with this?
Down to your right.
Down to my right.
Yep.
So I made a programmer and tested my circuit board to make sure it actually functioned. And found out I didn't have the right one of these and had the wrong firmware on it. And that was another whole story.
Yeah, you had to go off on a side quest to figure that out.
Yeah, and then I ended up buying 2 of those because I always buy 2 of things because one is going to fail or one may not work. And it's taken 3 days to get here, so why not? So anyway, eventually, the story, just to get the story along a little bit because we're taking a while, eventually 2 of these got programmed with the latest firmware, so Arduino IDE does not yell and scream at me and say, oh, no, you can't set that clock speed or something. It's a standard message for the firmware being old. They now work okay. This now programs okay, so I can use that. And that all functions. So now my blank Tiny 85, yep, in there is working and programmed, and the light does flash when that spins, which I will show you in a moment for those who don't believe me. Right, so we've covered how that got done. That was the hardware side of that end of it. Okay. It's a bit of a progress from last time I was here, I must admit, wasn't it? It's
changed a little.
It's just a little bit more sophisticated than last time. So I'll just put the cover back on there to protect it. And of course that means that by happenstance, the sensor is sitting right here, directly below the airflow. So it's not impeded and it's facing towards this side, upwards at the moment. Right, so that's, I guess I better make one. And I've got 3 different coloured cables, John, just for your, being how we are. I've got a white cable, I've got a red cable, and I've got a blue cable. So I'm going to have to print 3 separate housings, one in each cable, and colour code them so I know which is one, which is return, which is...
Gavin is looking through the round window.
I am looking through the round window, and there's a I've seen this movie. You have to put what was that movie? Stallone, wasn't it? You had the fan, you had to put the thing in it.
Oh yeah, to stop the...
Stop it so he could get through before it all exploded on him. So now we've got a sensor. That's the thing.
Was it?
Something
like that.
One of those ones. It was not the Adrian one, the other one. Okay, so then we started with a Node MCU last time, didn't we? Yeah,
I can't remember.
Yeah, it was a little dude, and I was going to go with a Fire Beetle 2 originally, and then I was trying some. Anyway, I reached into the back of my cupboard, and finding the right packet, found I had a bunch of these old D1 mini Arduino cloney things.
Oh, okay. Yes.
And I also found that somewhere in my deep dark past, I'd bought some little boards from something PCB Way or something. There was a little expander board, if you like, so you can plug that, which has got an ESP8266 on an Arduino Uno footprint. So it's a Wemos D1 R1, I think it's called.
Yes.
And then that goes into there, and you know they're the powery pins, so I know. They're the I/O, so I know. So I spent a lot of expense on these connectors, I can tell you. And it runs on 12 volts, which is an advantage. I haven't got a 470 ohm resistor in there at the moment to make the light come on, and it has a reset switch on the top. Has two I2C there, and a bunch of normal digital outputs there, which go over to that side there, and an analog in. If you've got a Leonardo, you can have 4 of those, so that you know all about those, and I'm sure that people in the audience do know. So at least now I've got some hardware, so I thought I'll get Claude to redesign. Like, he started designing something for the Fire Beetle. That was the story I showed you guys last time. And it got messy, as it does. And what do they call it when you start something and then you go a little bit and then you go a little bit more and suddenly you're nowhere near where you started.
Oh, yak shaving.
Yeah, it could be. It could be. Like a bit like your beetle body. He started with one life, and over here is a completely different beastie, isn't he? Right. So what feature creep? Is it feature creep, or is it scope creep?
That is a related thing.
I think it's scope creep. Right. So anyway, scope creep and Claude and I all get on really well because that's how our brains all think together. So I went, okay, this is literally a neat. What have I got department? What have I got in the cupboard I can use today that I can plug in code, get Claude to make some changes from the original information, and then add a bit to it. Okay, and I got a compile on it. It worked, and I got something to work, and I got one literally. Where's the connector? There into there, and I got something that actually came up and worked, and I could see the fan spinning, and I could get something happening, and I saw a light come on, so I was pretty happy. And that got that going.
So just to...
Now I'll shut up for a moment and give you a chance to get a word in.
Well, to ask a question or two.
Sure.
So at the moment you have the AT Tiny, which is on the little round PCB inside
It's
the
a rabbit
fan.
hole full of squirrels.
Yes.
They will come pouring out.
Yep.
And you need to connect 3 of those fan assemblies
Yep.
to the single...
At least two. At least
two.
Yeah, because when you look at the split system air conditioner, like yours inside here, we looked at last time, you've got air going, you've got what they call return air and intake air. Okay, intake air is the air coming in from the top, which is the hot air, and the return air is the air returning into the room. Okay, so what happens is the air conditioner tries to, essentially it compresses and either increases, well, normally, depends on whether it's on which cycle it's on, heat or cool. It'll try and either put more condensation into things or draw it out in order to make coolness or hotness, if you like, okay? It can't make heat natively. It has to recondition the air because it's an air conditioner, okay? It doesn't, just not a heater as such. So what you've got is on any air conditioner split system you've got at home, even the ones mounted on the wall, there'd be an intake at the top, which is the return. Sorry, the return's on the bottom and the intake's at the top. So hot air rises, therefore it goes into the top, it gets sucked back in, it gets processed by the fan and the compressor in the split internal module inside the house, and it gets forced out through the vents which come out towards you. Okay, and those are returns. So they return to the air, so the cooler air typically falls and the hot air rises. And what we're trying to achieve...
Gavin's OnlyFans channel.
It's my OnlyFans channel, exactly. Mr. Box, well done. Yes, I like the call. Sorry, I'm moving this around. So what we need is one of those there on one side, just for those in the audience who can now see what's on the screen. So you need one side here, you need the air conditioning unit here, and you need another one over here to sense what's going on between these 2 points. Okay, so this would be maybe the air, the hot air. Okay, let's do this proper. Mr. John, let's do this proper. This is our typical split system echo. Okay, the white at the top is the hotter air on the top because hot air rises.
I am Butterbox.
And then it comes down, it goes through the magical air conditioning unit, and then it gets compressed, and there's a fan in there that tries to increase the air pressure, which then comes out through the bottom at a different air pressure, a different flow rate, and that change in pressure and that creates a dehumidifying effect, as well as a heating or cooling effect, depends on which way you've got your cycle set. Okay, so the reverse cycle system just pumps the gas the other way. It pumps the heat from inside to outside or outside to inside, depends on which way you've got the heat or cool mode. Or you can just have dry mode where it doesn't do either, just pumps the air around. So there's a whole bunch of stuff going on. But I need a dual set of these inside to do my measurements for my class project, which is what I started with this craziness with. And so I need an identical set of these at the moment, hence the can I borrow back the fan? Because they should be the same synchronization, same settings, it should be the same elements, same electronics, so I can get a comparison between the in and the out. And then typically on the outside of your house, on a split system, yours has got you've got a box one that's in a window, haven't you? So that's all in. So the outside part of it in yours is just on the bit on the outside.
Yeah.
And it has kind of the same thing, but it's got a much bigger fan, you may have noticed. And the air conditioning refrigeration unit component of it is on the outside. So all of the gas conversion. There's a brilliant video that I've found for our students, which I put up, which shows you how it works, going from it goes to a fluid to a gas and a gas to a fluid. Is pretty much the way to look at it. And in that, it shows you all of the difference in temperature as you go through the length of the pipe. So it changes state and temperature quite dramatically within a short distance.
Okay.
Without getting too deep into it, I mean, I could show you a YouTube video. We can spend an hour on that. Anyway, is that okay? Is that too much information?
No.
No, that's
I'll
about
get back
it.
to my question then.
Yes, please.
Which was,
Yes.
you have the microcontroller inside on the little round board in the fan.
Yep.
And that is connecting to the breakout, which is
Here.
yeah.
Yep. Wherever that is.
And then you need multiples of these, which means that the
Somebody said
firmware-
multiplexer.
Yeah, and that means that the firmware, either a multiplexer or the firmware that is inside that AT-Tiny, needs to have a different I2C address so that you can have multiples of them on the bus.
Yep. So the
how is it-
firmware. So
Yep.
the firmware has a spare address pin on the AT-Tiny, which is not used. So you can either have two inputs from two different fan Hall effect sensors, or you can have one as an addressing pin.
Okay.
And when you tie that low, the AT-Tiny can be programmed to change the base address in the I2C bus. So, I've got a choice here. I can either have two devices on one bus and no others, or I can have one on the inside with one address and one on the outside with another address. Or, as somebody was mentioning, could we put them onto separate I2C buses? And that's one of the dilemmas that I'm at the moment. That's why I'm seeking your and other people's advice on how to attack this problem. It would be nice to have a single unit on a individual buses to be detected, then therefore I can interchange things rather than have to go into the hardware and keep changing a jumper pin or something, which is mechanically going to damage something, I think, if I do it too many times.
Is that something
What would
you
your
need to
take be?
frequently change though? Because
Um,
once you've got something set up, the way I would see this working is that you would have a convention. For example, if you've got the white or cream one you've got here, and you've got a blue one and a red one,
Yep.
then you would have a convention for what each of those colours represent.
And then give
And
them
you'd want to be consistent. So once you've set the address for each one of those, you wouldn't be changing it. And potentially you could configure it in the firmware itself.
Yep.
So I guess part of my question is, how did you set up the communications so that the in this case the ESP8266,
Yep.
can talk to the different fan boards over I2C. So are they being I2C slaves? And then you've got the master running on the 8266. And
So you're asking a question that I asked Claude, to be honest with you.
okay,
And I said, Claude, how would I do one of these onto one of these at the moment? And because I wanted to start with one. And it said, oh, okay, yes, just put it on the one I2C bus. We'll program it and lock it down just one. And it'll be a fixed address and it won't change.
yep,
And then, of course, I raised the thought that you've raised. How can I do this to more than one device? So again, I asked Mr. Claude again, how do I do this? And Mr. Claude said, oh, you just put a multiplex on
unmute
it.
yourself.
I mute myself.
You muted, are you?
Am I? I didn't think I was. I don't think I am, according to what the microphone says.
I see words on the...
Oh, hang on. I was muted.
Oh, you muted.
Oh, amazing.
You
So was my
Did it-
voice just coming through
did you hear
Gavin's
some of it?
microphone? It would have
Probably,
been
hopefully.
coming from a long distance.
You can hear both. Okay,
Yeah.
cool.
Thanks, Tinker. No, Tinker was correct. I had muted myself on
much
the
better.
microphone. Yeah.
Can you use a second hall sensor analog to change the tiny address?
I don't think that would really benefit you in any way,
Yeah,
because
mine
it's
was for you, yep.
it's just complicating it when you could just use a jumper.
So we get an echo because we've got two mics going on?
No, I think we're okay now that I've unmuted myself. So Andrew said that, yeah, I was being picked up via your mic, so I would have sounded quite distant.
Muffled, but there. Had to turn the amp up, and then
Yes.
everyone's turned it up, and now they're all going deaf because they're yelling at them. Okay.
Yeah. So there is a way, if you have a single I/O pin, there. Do you know if the I think it does. Do you know if the AT Tiny has internal pull-up resistors on its I/O pins? Do you remember coming across
There's
that at
only
any point?
two I/O pins
Yeah.
there.
Yeah.
I
AT
don't
Tiny 85.
recall off the top of my head. You're hotter than I am.
Okay. Yeah, Tinker, I'm running two mics into one receiver, and it's possible that the gain is set differently on the two mics, and I can't change it at the moment. I'm going to move my microphone further away from myself. I'm going to stick it down low on my shirt. There. Now it's further away from me. Hopefully it'll change it. So Stephen says if the I/O pin is analog, you could use a resistor ladder. Yes, that's true. But where I was going with this is that you can have more than one value into a single digital I/O pin, more than one in terms of high or low, because what you can make it a ternary pin where it is either left floating, pulled low, or pulled high. And the trick there, how do you do the trick? No, you can only do the trick if it's an I/O pin that you can enable both internal pull-ups and pull-downs, and I don't think you can do it on the AT Tiny. So my idea did not go anywhere. Charlie Plexing says Jack's Tech.
Yeah, so my thought was, I've got a jumper on there at the moment, it's a solder one, and it's sitting, strangely enough, right between, because, again, my friend Claude. My friend Claude decided that, well, I decided eventually that there, which you may not be able to see, actually. So that next to the chip there's, what's that, pin 2? Goes to ground. If I short that wire out there, and there's a little resistor there, in my first board production, I thought I would do it that way. Now, my second thought is to move that over onto a full-size jumper like these guys, and I can physically
just
easily
have a
plug
pin
it
header.
in. Put a pin header on there instead, and if I don't use the pin header, I can then put another 3-pin socket or something for another device. So if I want to change it from a fan one to maybe a water flow sensor, which is a Hall effect sensor as well, I can then I can rearrange my real estate and rather than have to design an entire different board for that use, I can use the same design board into a different perhaps housing, and it probably needs a couple of screw holes. So, as my observation after this, I need to put somewhere to mount this
something
on.
to physically attach it.
Yeah, because a bit of glue is good, but it's hard to get off again later.
Yes.
So that's where that started. That was the easy part. Okay.
Well, just before we move on from that, I can't remember who. Someone mentioned a multiplexer. That is definitely an option here. What you could do is set them all to the same address, have a multiplexer on the breakout board, which is the one that currently, I'm just going to reach into the view here. So this one has the I2C connectors on it.
Yep.
What you could do is you could have a board equivalent to this with an I2C multiplexer and then have 3 connections, or 4 or 8.
Yep.
And then you just plug different devices in and you can address them all independently. That would solve that problem. Then you wouldn't need to configure the individual fan units. They could all be set to a static address because it just depends which plug you put them into. You could have a plug for each of the locations.
Yep. So this is the outside sensor, the inside
Exactly.
sensor, and they're all exactly the same hardware.
That's right.
And there's no mucking around in hyperspace.
Yes.
Yeah, right, okay.
That's right. So that's, I think that's probably it is an option.
Said, seeing as it's an MCU on the board, should be able to set the addressing in firmware. Seems simplest.
Yeah, so that's the other option, is to load different firmware onto each one. So you don't need to reconfigure them. Once they are set up, if you've got one as the I can't remember the terminology you're using.
I'll take that one away.
Yeah, but if you have one of the fans set up, for example, as the cold air outlet or what?
Return.
The cold air return.
Yep.
Okay.
Yep.
You give it a particular I2C address in its firmware, and you set it when you flash it, and you never need to change it after that. So that is actually the simplest thing in terms of making something that you don't need to reconfigure. You flash each one so they've got their own independent sequential addresses.
Yep.
You plug them all into a shared I2C bus, and the central host knows the addresses of each of those things, so it knows which ones to talk to. So Tinker's suggestion there is simplest in terms of the electronics.
Yep.
If you wanted flexibility, then something like a multiplexer would do it. Device, outdoor unit. Yeah.
Yep. So this is the question you're raising, and the thing that I proposed to my good friend Claude, who was available all hours, rather than just on a podcast on a Sunday on random weekends, which is cool. And he went, "Oh yeah, could use a multiplexer, as you said, and that would save a lot of things you need. Sorry, that would save an awful lot of this."
Jono's heater fan was vibrating in me's foot.
Okay.
That's a good
I
trick.
don't know what that means.
That is very fancy if you did manage that. So eventually I went, okay, the path down the road in the Claude vibe coding, if we like to use those fancy words these days, it's seemed pretty popular, was, okay, look, just forget it. Yes, great, multiplexer, love the idea. Great idea, yeah, that would work for me, but I just need something working. So let's just drop the multiplexer originally, and let's just get on to writing some code for me. Okay, something so I can see some data and results, so I can see that when that spins, that code in the AT-Tiny actually functions.
Yes.
Right. So I set him on that little task instead. So we squirreled, as we do, over to software, and I did get it to work with the fan to start with, and then I had to choose, or had it to detect what kind of. I just started off with a simple sensor, and I've been through a few different revisions and sensors in my time. I'm reaching over to here.
Yeah, Gavin has a whole array of
I
things
have
set out on
lots
the
of-
bench over there.
You will not believe the amount
All
of
the
stuff that's
props.
over here. Right, so that is the brains of the outfit. A bit like John in this conversation, to be
Yep.
honest with you. Right, how far?
I'm the passenger.
You're the passenger this time, okay. Well, enjoy the ride, John, that's my suggestion. Right, that's there. Right, so that's the brains of the outfit. That's one of the parts of it. We can get rid of that part there, and I'll turn that way. left to right into out, wasn't it, John? That's it.
Yes, that's right.
Left to right into out. So we've got that goes into that by some magic. And then this is Wi-Fi, so there's no real out as such. But for the moment, that's cool, but I wanted to test it, so I made a little somewhat terrible jig out of some connectors, and I attached it to a SHT30, which is a
temperature and humidity
didn't
sensor.
we went through that, we took it apart and had a look inside. And we can do that again for the people who didn't see last time. And John magnified that up, and we discovered there's a tiny little point on there which does the sensing, and all the rest of this is conformic coded for protection.
Yes.
Okay. So my original thought was to put that inside here, inside there, which is quite bulky. Okay, but if I'm going to measure something, I didn't have enough fans organised, so I thought I'll make a little jig here that plugs into, not that end, but there was another one, and there is another one, there's always another one with me, that plugs into there, which brings that out, so I can attach that. So then I went from one sensor, because there was no internal sensor at that time, so I went from fan to sensor, one fan to one sensor, and the code got updated to have that functionality. So I can at least read temperature and humidity and rotation.
Yeah, speed.
Yeah, I could get those three working, which was cool. So it was all it's been a journey, I'll be honest with you. It's been a fun journey, but a journey no less. Of course, as we know, I'm not as experienced as, I would argue, intelligent as you.
Lies. Go on.
No, it's okay. It's all a different scope and a different travel in the world, different journey. So I, rather than keep bothering people such as yourselves with such large brains, I went, okay, Claude, do what you can. We'll work it out. We'll come back and ask John if I have to. And I think I've maybe rung you, maybe once, asked you a question, right? So this is all.
You've made a lot of progress with
I've
this.
made a little
This
bit of
is
progress.
Very different to last time I saw it.
It's a little different, isn't it? Hendrik would be proud. Right, so so basically now I've got an I2C bus which has got a device that works and another device that works. And then I went, well, there's that device in there. So that device in there was originally outside the second sensor, because I wanted the software to show me graphically. And you guys cannot see it, but John cannot see it either at the moment. There's a whole piece of software written around this. So the guys at work, we had some simulation stuff which showed, did I show you that last time?
Yes.
Right? Okay, it did simulation, but it didn't do real live, correct? Because we didn't have any input sensors.
That's right.
So then I modified the code to take live data and merge that into the interface. So when you put your hand on this sensor and hold it, the graph moves up on one sensor. And when you put your hand on the other sensor and put your up, the other graph moves up. And you see the whole dynamic changing. And when you let it go, they both drop because your hands are warmer than the air around you.
Yes.
If I put them both at the same time, they tend to go up at the same time. When I let them go, lets it all drop down.
Do you have HDMI out on your laptop to show it? Because
Yes.
potentially we could hook it up. I have an HDMI cable here, which I think goes
Might work.
into the ATEM, and if we plug it in, we may be able to
Sure.
show the people
We can
what
give
you're
that a
talking
go.
about.
Yep. Is that one mine as well?
It looks like it.
Yep,
Yes.
that's right. It's okay. Oh, that's right, that fellow there. Yep,
If
so
you're willing to,
I'm willing to share it.
playing around with it.
Now, we can actually, I've got, okay, I'll go forward about another month. Okay. So essentially what happened was I also wanted to, is there
a smell?
Smell sensor. Probably.
Not yet.
I haven't got one of those yet. So anyway, marching forward a lot, and what you're saying is correct, John. There might be an easier way, or there might not be an easier way. It depends how you look at it. So by default, I had to hard code because it's an ESP826. So I had to use the the library for doing Wi-Fi, and I had to put in an SSID and a password.
Yes.
Okay, and that wasn't in the sequence.
Come along across this way a little bit.
Everyone needs a Gavin.
You got one today? Sorry, I'm focusing on what I'm doing and the talking right more so than the picture. It's not a very pretty picture. So as we know, if you've got an ESP and you set up a basic captive portal and you put in some ID addresses, SSID and password, then you should be able to connect to your local network. And then they go to fail back, isn't it?
Yeah, typically.
Yeah, so it'll go back and pick an address, it'll call itself something, it'll let you set a new
reconfigure it if
address and
necessary.
reconfigure it. And so initially I hard-coded my details into the secrets file, which is cool until I come to move it somewhere. Like to come visit John and you guys to show you how this works, and suddenly you know the details of my passwords and everything from home. So we know John doesn't like doxing people, and I don't like doxing people. So what I thought we would do is I would change it to a 4G one, which I'm testing another project for us, for the office. We need an online timetable.
Yep.
So I have a 4G Smart Modem 2 Telstra account with the username of timetable and the password of timetable,
Okay.
which is connected at the moment. So if I disconnect from that, oh, hang on, I need to step back a step. Sorry, John. I'll take you back a little bit further
All right.
forward or
A
backwards.
little more
okay?
explanation.
All right. So what happens? What happens after that?
Excuse me, Gavin.
Yes.
What is the circuit on your shirt? It looks like a basic power supply.
It's whatever it is. It's just a positive, negative. Oh, should I show? It's just a shirt I bought from. Yep, it's a what do you got? Rectifier
Yeah, looks.
through a positive, negative regulator. Yep,
Yeah.
and then output in the filter caps and stuff. So it's which part of this don't you understand?
Yeah.
It's just a standard AliExpress shirt. I'm sure other people have seen. You can buy those. There's no problem. I thought in the electronics theme today I would come in with this.
It's appropriate.
It's appropriate and it's crazy as. Right, so that's cool. No troubles, Mr. Box. So what I did then was great humidity, temperature, relative humidity I could calculate, dew point I can calculate. God damn it, air pressure changes with altitude.
Yes.
So what's the easiest
does.
way to get altitude?
To get altitude.
What's the easiest way to get altitude?
What is the easiest way to get altitude? GPS.
Stick a GPS in this puppy.
Okay, let's go back to here.
So where am I?
Going to the right.
Make
Yep.
life complicated. Box. Add a $6 GPS from Core. I don't exactly know the model number at the moment, but it plugs into the UART port. So that means I've got to get 3.3 volts from over here, a ground from over here, and my RX pin from over there onto a unwired header, which I have wired up. Not in this particular one, but I do have another couple which are, as John can see, wired up and all functional. So next step, let me just disconnect this one for the moment because that's going to kill that.
Easiest way to get altitude is to climb.
Yeah, so the all the mathematical stuff.
Climb, climb, climb.
I'll see if I can bring one over. Have I got two? I've got two. I told you I've got two. I've always got two when I do things. I'm going to show people I've got two. Right, so then, okay, I'll replace that one and that one. That one. Oh no, John, I've knocked that over. I'm sorry.
That's okay.
Oh, there's pins everywhere, man. Sorry.
That's all right. They can,
Okay, so
they'll just go into the bin.
so then
eventually.
we've got GPS here. We've got UART there. We've got that. Pretty much there. We've stepped from one to the other. We're working our way through. So now, at that point, I got to the stage where I now have altitude, which will affect my psychometric charts. Sorry, whatever that word is. I always
whatever
get,
that word is. Yeah.
you know, the one that
Pull up.
pull up, yeah. So GPS will give me satellite location. It will give me altitude. It also gives me time.
Yes, that's true.
And time
Very
means I
nicely.
can use a local timing thing. That might come in handy sometime. So I've tried it. But it has a sacrificial thing. Arduino uses the serial console to look at stuff.
Yes.
So if you open the serial console or you work with the GPS connected while you're programming it, it don't work.
It's
contention,
an
but-
8266, which means you're very limited.
Yeah.
With an ESP32, you could run multiple UARTs.
Well, I might change that in my next design, but this was a quick and dirty, what have I got in my cupboard thing. So, yes, I think you're right. I know you're right, because you are right often, more often than not. And I had thought of that, and I'm thinking I've just got to do what I've got, and I haven't got quite the knowledge yet in KiCad to do that design level. So I'm still working, I'm still learning. Early days on my brain. So as it stands at the moment, I have to unplug the GPS
To program
the firmware. Otherwise, I get a conflict or
Yes.
COM4 blah 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 message and a whole bunch of up and down lines come
Yes.
up saying that. So my last couple of days have been, oh no, damn, it's plugged in. Unplug it, have another go, plug it in, unplug it, and to get it going. And it did work. So we got to the point where I've got altitude, humidity, temperature, sensors, how do I see what's going on if the serial console's gone? And how does one do that, John, do you think? Anyone else in the
Sorry,
comment?
my brain is just back on the other serial console issue.
Yeah.
And Stephen44799 pointed out you can just run a software UART if you need, as you have plenty of CPU.
Yeah.
Yeah, so typically, most commonly, GPS modules speak a format called anemea,
Yep.
and
9600 board.
in fact, it's often even slower than that. They typically default to 9600. Sometimes they used to default to 4800 board, which was bizarre.
Yep. Because everyone uses 4800.
4800, yeah,
Everyone.
very common.
It's common as.
But it's, in any case, it's not fast. With modern ones, it's pretty normal to run them at 115,200, which is a problem for software serial. But 9600 is perfectly fine.
Good sweet spot, isn't
You
it?
could software serial that, no problem. It'll handle it. So you could just move that onto another arbitrary pin, set up a software serial interface,
Yep.
and receive the NMEA signals that way.
Well, that's one way. But, you know, Gav being Gav goes, Mr. Claude,
Do the debugging
how
over
can I
Wi-Fi.
see something I can't see?
Okay, and what is the solution?
One of John's little friends.
Oh, okay.
One of John's little
A
friends.
display.
A little
Yes.
display.
Put an I2C display on
Which
it.
has got an I2C display device. It can be detected by the system to tell whether it's there, and it will work at boot time, so I can see what's going on. So I plugged one of those into one of the other UART ports, sorry, into the
I2C port.
I2C ports, and then I can see, or could see, what was going on when it fires up. I'm not sure what software's on this one at the moment. So the little red light now comes on. Don't know if we can see the little red light from there. See the little red light there?
Oh yes, there it
And
is.
when I spin it, the little red light.
Ooh, little flashy lights showing that the Hall sensor is picking up the magnets.
Yeah. So it's picking maggots. It's something definitely happening there. And then over here, on a really small screen,
Ah,
I can see zone A return sensor error. I can see zone B supply. So it's saying at the moment warming up, which means that says the word warming up. John can verify that. So the sensor needs a little bit of warm up time, stabilization time. And then when that comes clear, that screen will then move on to the next setting,
which it has just done, I believe.
which is done, which is the SHR, which is a sensible heat ratio, which is the comfort level. And we're aiming for somewhere around about 0.5 to 1. Is the
We're at 0.45 right now, according to that.
Yep. Now,
Which
that's-
is why I'm uncomfortable by
yeah.
0.05.
Oh, it's human stuff. So there's a sensor there missing, which is the INA226, which I haven't got fitted onto this particular board at the moment. So that's another feature. We have to wait for that to time out. And there's the IP address of my device. and I'm getting a sensor error on zone A, so there's something wrong with something. Oh yeah, there it is, the problem, it's not plugged in. There's the drama. So once sensor A is plugged in and sensor B is plugged in, I've got my 2 points of reference from my return air and my supply air. I'll get humidity and all of the 4 things I need there on that, and I'll get the 4 things I need from here, and that's when the magic in that software we showed last time works. And 192.168.1.1, that's no GPS, so it's got GPS tracking as well, so it'll show you the GPS, which for some reason in this firmware, which I did this morning, there's no flashy lights going on, I'm not getting any signal. But I think it's a firmware issue I've created last night, or this morning when I put that on.
When you say no flashy lights, so there are no flashy lights on the GPS?
No flashy lights on the GPS, but it was flashy lighting, and I was getting satellites last night, and I've been getting satellites at home reasonably, maybe, I don't think it's, I'm no detection of GPS is the thing, it's not seeing it. So we're starting to get some values out of that sensor at least, and if I had enough connectors I could plug that one in, and now I get my 2 sensor input. Okay, so now I can see what's going on, which is helpful. This is growing sideways like one of your squirrels, isn't it? Okay, it's going good though so far. So I got to the stage eventually where I've got 2 sensors working. I got the software working. We'll come back to the software in a minute, John. And I had enough hardware, and I could see the hardware on my Wi-Fi network quite happily. And I was getting some information and stuff coming out of it. And then, of course, I went, okay, I need to do this on more than one location. I need more than one of these units. Because, amongst other reasons, I also want to get the outside air temperature. A separate third sensor, another Wi-Fi one potentially. I haven't quite got the master-slave part of that figured out. Well, Claude hasn't yet, because I haven't asked him whether we can bind them together somehow. But I did have a think about Home Assistant. Because Home Assistant's got capabilities to discover devices on a Wi-Fi network, doesn't it?
I don't know.
Auto discovery, so it does.
Okay, I believe you.
Yep. So in Home Assistant, when you plug an MQTT, if you configure the MQTT service, put the add-on in, and you can create an account. What's that? No smoke, that's a win. Absolutely.
Yes.
That's so Home Assistant has a feature which I use all the time for power plugs and stuff. So each one can locally auto-discover a device on your network. Okay, so it pops up and it does a MQTT request to a broker. In the current version, it can't do anonymous login, so you have to give it a name and password inside Home Assistant. Otherwise, you get an RC5 message back in my software saying, I can't talk to him because he won't talk to me. He won't accept me. That's obviously a security thing, and that has to be taken care of. So my thought was, this can show me instantaneous data. If I can get this to talk to Home Assistant, I can get long-term duration data. Days,
and
weeks.
let Home Assistant do the logging.
Let it do all the heavy lifting and logging for me inside there. And eventually I figured out that if you do go into Home Assistant and MQTT, add the user, and I called it HVAC and HVAC because that was nice and simple. Easy password. No one's going to steal it anyway. It's not that exciting. And I don't know, by the miracle of magic, I put the details into Claude, and Claude managed to say, well, I think it'll talk to it now. Go. And Home Assistant did in fact talk to it and discover the device. So now I've got logging going on inside there.
Okay.
Long-term logging, altitude, all of the sensors that are on here all report back. Okay. To Home Assistant, and that logs it for me. So I can see altitude drift in the GPS, I can see longitude, latitude drift in the GPS, so like positionally. I can see all sorts of bits and pieces out of the... Whatever's there gets pushed out to Home Assistant, which is kind of cool. No smoke, add an I2C SD card. I hadn't thought of it, Keith, to be honest with you. I like the idea, I really do. But I didn't go down that path for the moment. But yeah, I'm taking every bit of information on board. I'm glad you were recording this, John. So I managed to get that to work,
I'm just knocking stuff off.
and of course that worked. And then I thought I did what everyone, typically does. I put another one on the network. And then what happened? They both reported to Home Assistant as the same ID.
It's the same device. Yes,
so
okay.
So they
now you
decided
need-
at that
that's right, you
point,
can-
everyone,
that can
we
stay
don't know
there.
who's on first, we don't know who's on second.
Yep.
And I could, as I plugged in 3 and 4 of them, 3 or 4 of them all said the same thing, and I had 4 entries with the same name on it. I had data all over the place. So how do you overcome that problem? How do I uniquely identify a device on a network?
Well, you can do it based on the identity. Oh, Mitchell. Let's see if the TTS does the music.
That means I've got to dance
We're
again.
about to find out.
Hendrix not here.
No.
Doing the
Thanks,
song.
Mitchell Eminar. I don't know what a ZAR is. I don't know.
We'll take 14 of those.
What
We
are
like
the
that.
14 of the ZARs?
No magic smoke. Damn, hey all. Hey there. Yeah, cool. All right. Sorry, my brain is
Yeah,
doing,
so we were
doing
talking
what it
about
does.
identifying devices.
So then I had to identify uniquely which one is which.
Yeah.
If I've got one in one room, one in another room, or one in a corridor and one somewhere else, all of them with different IP addresses, but the same ID, Home Assistant is no good to me whatsoever.
When you say ID, is that a Home Assistant?
Yeah, so it
attribute.
discovers the device as and has a name. So
Okay.
the device will send a name to Home Assistant to enroll into the broker, and then if you've got that, puts it into the subscription group, you could say. Is that how it works? Typically,
It depends on
subscribe to a group.
how you have your channels set. Well, not channels. It depends on how the topics are set up. So if it's publishing to a topic which is based on the device name and they all have the same device name, they will all end up publishing to the same topic.
Yeah.
And then the data will all just be jumbled together.
Yep. So what I did is, how did I find this out? When you do something, there's a device ID number, which is based on the MAC address, I think.
Yes.
So then I got Mr. Claude to
Yeah, append the MAC address
append
or
the MAC address
device ID
to its unique
disambiguate.
one.
Yes.
Yeah. Yeah. So then it identified that.
Yeah.
So then at that point, I gave every board a different board name and a different host name. Wagon loads, you are so close to where I've got to. It's about $1.
$1.40 Australian.
I will take it.
ZAR is South African Rand. Oh, okay. Did I come back with a drip? Thanks, Mitchell.
Yeah, so so this is like an ongoing journey. I know I'm telling a long story. It's like the world's worst bad joke, isn't it? Dad joke, isn't it? So the journey's been long and fun. There's been a lot of interruptions with it. And I got to the stage like we're sort of going along. We get the queue, get something into Home Assistant, get that to work, step, tick box. Get the device ID unique, step, tick box. Next point here was, can I name the machine or name the board to a different name?
Yes.
And I said to Claude, can you name the board or device after it's been discovered to a different name? And it went, sure, but we'll need hang on, there's got to be a settings box where we can put all the settings in the software. So it added an option to update that detail.
And then it saves it in non-volatile memory.
Keeps it in non-volatile memory for it'll survive a reboot.
Yep.
Also, the Wi-Fi name and password are in a settings
also
box,
stored. Yep.
which can be changed. So we've got control of that. We've got control of the names. We can tell Home Assistant what we want it to do. So I can identify, put the word kitchen or something on the end of the MAC address, and it will start publishing to that one. So yes, it does now do all of that in the software. I know you want to see it. So it's on timetable. It's unplugged over there, but we'll get around to demo any second. How are we going for time? I know we've
I've got about 20 minutes.
okay. I'd lost track of time. I thought felt it was close.
It's very easy for that to happen.
It is, isn't it? So yeah. So basically, at the moment, it's set to timetable. which is the access point there. If I turn timetable off, it should fall back to the fallback point.
Yep, to being an access point.
And then in theory, we should be able to attach it to your network directly. But I probably want to, do I want to show that part? Because the software may be it's a bit soft or slow in responding while it's in that state. And I think it's normally faster, but I think because it's having trouble with the GPS for some reason, it's waiting on something there to go on, which doesn't happen in the software. So it's just, I noticed when I was testing it this morning and last night, which is a last minute thing as one does. Yeah. A bit like your software there was this morning. We were having a bit of a challenge, guys, this morning with the software. I'm really proud of you, John. You didn't say any swear words while you were doing that too. I was really proud of you.
Not out loud, only in my head.
No, in his head he was swearing away, but outside there was no words coming out of his mouth, which was sweet. Yeah, so I tried it last night thinking, oh, if I go to John's and I got my my passwords in it, well, that's silly. So I got it to do keeping the variables in there, and I tried to test it last night, but it was a little bit late. And I think it works. Okay, I think it works. So I think we should go to live demo if we can try it.
Yeah, let's try a live demo. So but my question I have is, why does
John have a metal roof? Yes, he does.
I do. Yes, I don't. Okay, so I've got to push something onto the stack. I'll come back to that question. Yep. And so this thing about the metal roof, I think, is in relation to GPS not working, and.
But there's normally a flash when you start it.
I think the issue is not that the GPS doesn't have a lock, and that would be the case if the signal was blocked. I think the situation is more that the ESP isn't even talking to the GPS module.
Yeah.
Because even if GPS has done a cold boot and it doesn't have a lock yet, you can at least talk to it. But right now, it's not even talking. So there's some more fundamental communications problem going on.
Yeah, up until last night, there's a light comes on when you boot it on here that comes on and up in this corner somewhere, and then once you get a lock on it, a different light comes on, and I've noticed that first light hasn't come on for some reason.
So it's not even.
So it's just not. It's maybe powering up, or I don't know. I just have to put my head around that one a little bit later and have a play.
Okay.
So I think that's going to slow. That's slowing down the response on this guy here. Hence the delay. That's warming up because I've just turned it on and off on my little portable power pack over here.
So, is there a particular reason we can't do it using your 4G device?
No, it is set up on my 4G, and we can bring my laptop over and show that now, happily to do that. Yep. I can move this over there, off to one side, and bring the laptop over.
Out of the way slightly. Or we can even just leave it where it is, and we can put the laptop here, plug this in, and we'll see if we can capture the screen off that and show what it's doing. Well, so
we're on battery and the laptop. Where's the HDMI on the back there?
On the back.
Just there.
Okay. Let's give that a shot.
There's nothing secret squirrel on this laptop.
And if we switch now to... is it okay for me to show that screen now?
Sure.
There's nothing. Okay, here we go. And we are now pushing out.
So this one is currently set to .100, and this one is set to 83. So I'm expecting a.
So right now, the people will be able to see nothing except the laptop screen. Yep. So that is just spinning. It looks like it's trying to load something.
It's trying to find a non-existent web page because I've done it on a different machine.
Okay. So we need the IP that's been assigned now.
Yeah.
And is your laptop successfully connected to your mobile internet?
It's not the world's fastest laptop either. I believe it is. It's hooked onto timetable.
Jack Tech said some GPS don't put out NMEA until locked. Yes, that's quite possible. I'm not exactly a GPS expert. I've used a bunch of GPS modules.
So I do have some valid data.
Ah, cool.
So we have supply air coming in. We're on the right one at the moment, so it's behaving better than I expected, to be honest with you. And then so we've got our dashboard, which is here. We've got the psychometric chart, which we saw last time. we have a console now, and we just have to wait until we get this setting updated to your network or something, and then we could take over from your network. There's an I2C scan, so it will scan for all the devices, and there's a JSON API output as well now, so we can output all of those things.
Okay.
Yeah. So again, I think it's a timing thing. I think the GPS. There we go. So if you
Is there a particular reason for connecting it to my network rather than just
I just
using it
wanted
as
to
this?
see if it would work. Is that a thing?
If you like.
Well, I've not tested this before. Then I can turn timetable off, and you can. Would that work for you, or is that too? If you're not comfy with it, we can try it. If it doesn't work, I'll just turn it on and off again.
No, it's okay. I just wasn't sure what we were trying to achieve.
Yep.
Okay.
So we'll hide that so nobody knows what your passwords are.
That's the idea. And I'm just going to find the trackpad on this unfamiliar laptop.
Yep.
Just making sure that this screen is not going out. Yeah. Henrik is here.
Hendrik made it. He's hiding and he's waiting for me to dance. I'll dance. I don't dance for free, Hendrik, I tell you.
He just wants to hack into John's office.
He does.
Yeah, so I have just given Gavin the keys to the kingdom. Save and connect Wi-Fi. So what will be happening now
Applying, the device is reconnecting.
is the device will be reconnecting to my network in theory.
And then that
and the
should
laptop
change.
is not connected to my network, so it's not going to be able to see it.
Yeah.
Applied, the device is reconnecting. So has it been given an IP on my network,
It's got that one at the moment.
which is the same one that it had before?
Now it might cycle through and change
We'll
that.
see if it connects to my Wi-Fi.
Yep. And that would have written that into the E2 prom, so it should survive This is a live demonstration.
Sorry, I was sleepy, just woke up like 5 minutes ago.
No worries, Henrik.
No
Thanks for
worries,
coming
Henrik.
along. Don S. asked, is this device used for a heat recovery ventilator? So the very brief summary is that this device is part of Gavin, a work-related project for Gavin, where he teaches air conditioning related stuff. So this is for applying sensors to the different parts of an air conditioner to analyze its behavior. I think that's a very short version of what's going on here.
No change there. I'm going to do a reset.
Okay, do a reset, yeah.
Might even do a full power cycle, might be a good idea.
No, the
I'll do
reset
that.
is probably
Reset.
enough. So
Alright, and then we'll see if it finds.
comes up with a different IP on my network, and then if it does, I should be able to hit it with a browser and see what goes on.
It reckons it's 192.168.1.100, but I've got a feeling that's not your address, is it?
Yeah, 192.168.1 dot something.
Try 100. It thinks it's 100.
J, fine minutes, not 5.
And if it goes terribly wrong, it's because it's gone terribly wrong.
Gilco asked, how do you determine when the KO has finished moving? Okay, that is definitely a squirrel.
No joy on that, John.
We're not getting the .100 coming up.
And we've still got .100 over here. I'm going to go with. I think it might be still bound onto this one. I would have thought.
It might be. So it might have gone to
I
your
need
network.
SSID and add it onto a new display here so I can see which network it thinks it's on.
That's true. Yes.
That's a feature creep.
Yeah, have it describe what it thinks it is. So the okay, very quick answer for Guildco about when the KO is finished moving. What I am doing this is a stretch of my memory, but in OpenKO, it is using the native position reporting coming from the KO motion controller and converting it to a G-code position response, position value.
You do know what I forgot to do?
What did you forget to do?
Turn the damn thing off. I thought it was still there.
Oh.
The timetable still exists as an AP.
Yes. But wouldn't it try to connect to this? Amanda! Pizza fun from Amanda. Thanks, Amanda.
Could have been a bug, John. We'll see.
Could have been a bug.
Could have been a bug. We'll keep going with that answer.
Princess Fiona
Okay,
made
yep.
amazing pizzas last night with homemade
It's local.
pizza base, etc. Yeah, they were fantastic. Very,
In
very
way
good.
back, but what happens if you type the Wi-Fi credentials wrong? Does it go into boot loop?
Don't know.
It's gone back into captive portal mode
Portal
now.
mode, okay.
Yeah, so it's in 192.168 dot.
So we would need to connect to it and then
Yep.
set it to something.
Yeah, so I'm trying to get my laptop to find it.
Yep. Okay. But if you turn your 4G internet back on, it'll probably connect to that because it probably still has those credentials stored, doesn't it?
Yes, I want to test it without it. Deliberately. That's when it came up. There we go. Right, so we are connected there.
Oh, Henrik is contributing too.
Does that mean I've got to dance again? Yeah.
Henrik just wants to see you dance or slip on the banana peel.
Hendrik,
Okay, Henrik.
there's a dancing monkey for the day, mate.
I hope you're satisfied.
4.1, wasn't it?
4.1.
4.1.
Yeah, 4.1.
4.
Yes, that'll be the captive portal address. And that is also not loading.
This is slow too.
Oh, okay. It could just be the laptop taking its time.
Latency. Phone works fairly fast. I saw that this morning, so I know it does work when it does work.
All right, so you know that it's working on your home network.
It definitely works on mine at home.
And you've had it working on this mobile, as we just saw a few minutes ago.
Yep.
It's been working on this 4G device. So
It's a timing thing. Yeah.
it's just getting it onto my network, which
it's
is
a-
not working right now.
Which is not. Yeah, it's on Superhouse instead of.
Ah, yeah, so your laptop had gone
It's
to the wrong
decided to grab
network.
that one instead,
Instead of being on the captive portal address.
which will time out after so many seconds, won't it? Okay. So
Yeah, so now you are being a dancing monkey chasing
I am
your
doing.
tail.
Yeah. Anyway, suffice to say. Okay. Yeah, we can continue on with this a little bit. If I can get it connected, that'd be really cool. I know it's what is it now? We've got 10 minutes, have we? Is that right?
Something
There's
like
something
that.
that makes YHE code slow.
Something that makes the code slow. No, it is not. It's not really the code running slow. It's more just a case of it takes a little while for Wi-Fi stuff to happen. So if the device is being rebooted into access point mode, it takes a little bit of time for it to establish itself as an access point, and then it takes a bit of time for the laptop to associate with the access point, and it's just, yeah.
And it's a slow laptop as well.
It just takes a little bit to get things done, and the access point mode can time out if you haven't connected to it quickly enough, etc. And yeah,
And I'm quite happy to share the firmware so you can hard code the thing into the sequence file and avoid all of this, which is what I did initially, was put the right values in. So there we go. Now it's in captive mode again.
okay. So now on the laptop you might.
Now
be able
we've got to
connect
have to find it. Is that
So
refresh?
while you were looking for that, there was a quick nerd brag from John Whip. Said, my Drobo 5N gave up after 13 plus years of faithful service, and I now have a Ugreen DXP 8800 plus. Don't want to hijack the stream, but any thoughts for TrueNAS versus UGOS? I want to run VMs for LLMs. I do not have any thoughts on TrueNAS versus UGOS because what is UGOS? Is that, is there something I've missed here? UGOS, because I've looked into NAS UGOS Pro. Oh, okay, it's Ugreen's own NAS operating system, but I have never actually seen that. So I have no idea how that would compare to TrueNAS or anything else. So is this a situation where... All right, ran Ugreen OS, yes. Sorry, I do not have any opinions on it. But if anybody else in the chat has opinions on NASs, so UGOS Pro versus TrueNAS versus any of the other particular NAS operating systems, please share in the chat. And Vic has Nerdbrag. Anyone else going to Sci-Fu Singapore? You're going to Singapore. Ah. Yes, I'm jealous, Vic.
He's got too much time and money, that boy.
Or something.
Oh, did I say that loud? Sorry. Good on you, Vic. Whatever you can do, brother.
Yeah, nice.
Still trying to connect, John. What shall we do?
Okay.
We cry a little?
Yeah, cry a little.
Cry a little. Okay.
That does help sometimes. Yeah, okay.
Hello, Moto.
Hello, Moto. Yeah, I'm just sort of try my phone as an option B if that didn't work. I can put the timetable one back on. I can get that to work and display on here.
Yeah, I think
it
that's
might
the
work
easiest.
better. Would that be
Yeah.
easier? And I can glue everything together because we've got so
Yep.
few minutes left.
Yep.
Okay, all right.
So you just want to show the software? Is that the
I
the
just
goal
would
here?
like, well, the
Show
goal
a
was
little
to
bit more about
show off, really.
Yeah.
No, it wasn't really.
Yeah. Vic says, found a sponsor. Awesome. That's really good. I'm glad, Vic. And yes.
So I had to make...
I want to hear about Sci-Fu Singapore. So make sure you report back afterwards.
So lose that sensor. I'll take that one out because that one exists over there. I'll attach this one to...
Is that booting again now?
I'm
Or
doing it right now.
about to?
About to.
The mobile? Oh, will do. Mid-November. Oh, okay.
Right, it's starting.
Some time away.
Give it a minute or two. That'll do it. This one goes onto that one. Get in there, mate. Get in there. Just got to get everything hooked up again one more time. And no, my luck, everything will decide to work then. Oh, there's the other one. All right, that's with everything. All right, this is my Dalai Lama one. This is one with everything. So I didn't have something which would bus things, so I made a...
Oh, it's an octopus connector.
It's an octopus.
For the I2C.
Yeah, it's not attractive, I can tell you.
Looks functional though.
It'll work. As you pointed out, if I had more buses and cables and things, it would work, but for the moment. So it's got a light sensor option. I'll try and option it up fully. It's got the LCD, it's got the light sensor option, so it can detect the illuminated light.
That's a little bit off camera. Just move it
Oh, yeah.
a fraction and
Just
then
trying to get everything back on. So
there we go.
So we've got display. We've got, I might just turn that off while I'm plugging everything in. Right, let's do this properly. So sensor device is cool. We've got that, which has got motion and that in it. We've got GPS, hopefully, or maybe not. We have got display. We have got 1750, I think it is, light sensor, so it reads lux.
Okay.
Okay, and I need this other sensor, which is our one of those
Temperature and humidity.
temperature humidity sensor, and that should be a full set of everything. And then fingers crossed that access point is still booting up, but it won't be long.
So this now should be booting. Oh yes, the screen has come up.
Screen's coming up.
And if the other access point finishes booting, this one should connect to it. We hope.
It says connected to 1.100, so that's cool. Yep.
Okay. Well, that seems hopeful.
Yep.
So let's see if your laptop can connect to the same Wi-Fi.
Yep. Timetable connecting. No, I turned it off. That'll be right. It'll find that now.
Timetable.
Connecting. So that's lights are all on. 4G's up. It says no internet, but it'll catch up on that one.
Yep.
And then
Now you should be able to go to .100, 1.100.
Oh, 1.10. Did I put in 1.10?
1.10 minus was just your enter. That should get you there.
Oh.
Connecting.
Nah, hang on, just kill that, kill that.
Oh, avast!
Oh, no. Like a good... What is going on now? Now it's locked up. Oh, nothing... Oh, there, we're back. Right, cool.
Right now the screen isn't being shared anyway, so
that's all right.
no one can see
So
what you're
no
doing.
one else
Once
will
it... No.
You're smiling and I'm screaming inside. It's all good.
So if we can get it reconnected, I'll switch it back to showing
Yep.
the screen.
Anyway,
Has the access point finished booting?
yep, it's all
That
up.
all looks up and happy.
That's all up and happy. It's just the PC's decided that it's lost Wi-Fi again, so it's got some Wi-Fi connecting to. All good demos. It just decides, I don't know what happened to this laptop. I don't normally use it for this kind of use. I use a full desktop like you do. So it's connected and secured, so it's got internet access. It's just Chrome's letting me down now.
Maybe it will be happier now.
Right.
You said segue to Access AP project.
Yes, Keith. It's been a while since we talked about that one. Where's that one? In a box somewhere?
It is in a box.
I think it's in the box somewhere. Okay. I'm going to cry, John. Okay, if you're looking for me, I'll be in the corner. If
Okay.
you hear the crying and weeping, that'll
Because
be me.
Chrome does not want to launch on your laptop now.
Chrome's decided today, this very moment, not to launch.
I hate computers.
Yeah, I know.
Undecided. That's it.
You know what?
I'm done
I'm
with
just going to
computers.
do one of these reboot things, just briefly, because it'll be quicker than... In fact, this is the fastest reboot I've ever done. Watch. Yeah, that's how fast that was. Let's do this again, because it's much quicker to start from scratch. That's all down.
Just don't make Windows angry.
Worst it'll do is crash. It's not the first time, won't be the last. Anyway, where do I go from here, John?
Good question. Let us
I'm liking your Mux
flick
idea.
Back to...
Oh.
to...
Everything's going pear-shaped.
Back to here.
Back to here, back to
Yes.
us.
Stephen says it's Gav's
Happy
party
man,
and he'll cry
happy
if he wants to.
Happy man, grumpy man. Gas party, he'll cry. Yeah, I'm not going to cry by choice. Okay, that's... Nah, it's just not happening.
Stop reading.
No, the lights are on. The light is on.
The laptop is being strange.
No.
No.
No, just not a day for it.
Oh, there it goes.
Now it decided to work. Right. Wi-Fi's up. Chrome will start. Life will be wonderful.
It'll all work this time, of course.
Tom, yeah. Take 2 reboots and call me in the morning. Looks like another stream, Gav. Yeah, if he'll have me back, that'll be the argument.
Got to make some progress.
Well, I think we've made a little.
You've made a lot so
We've
far.
made a lot. It does say 1.100. It does know where it is. But we can see that. We can see that. We just Chrome has decided, just right now, as one would expect, to misbehave. So, path forward with this, John. I know
Yes.
it's 12:04 according to
Next.
my clock, and I know you have somewhere to be today.
I do. I have something something kind of unfortunate I have to do today,
That's right.
but it's an obligation that needs to be met.
Right, so what do you suggest, mate? My thoughts are, I'll give you my thoughts and then you can give me your recommendations based on that. I need a Mux, I think. Might be the easiest way, because then I can... Oh, the other thing is these devices cannot be readdressed.
Okay, so
These
if
are
you need...
fixed and they're locked and they're bolted together, so you
Yeah.
can't change those. These ones, these little
Hang on,
sensors
I'm just
cannot
going
be
to switch
addressed.
the view back to the overhead.
Yep.
There we go.
So these ones cannot be addressed. They've got one address.
Yes,
These guys only have one address and can't be changed.
yes. And you do want multiples of these, don't you?
Yes, yes. And there is another one, which is a different style of housing, which I think we had last time.
Yes, we did.
I'll have to Indian give you on that one as well, so I can get two. I will get replacements, by the way. I just have to borrow them back again so I can simulate two installations. So this one also has a fixed address, which happens to be the same address as that one. Now I can go to an
SHT30
41.
or 41. Yeah.
I think this is a 31. I think a 41 is a more accurate one. It's point something of a degree percent accuracy. So I could put, that's an that's a BMP 280 in there, that little guy, and an AH something 10, HT10. So it does the air pressure as well as humidity. So it's doing that as well. So I'm thinking if I go for one of those, sorry, put it in the picture. One of those.
Oh, after all this time, your computer has finally decided that it's going to start launching Chrome.
Yeah, it does that. It's it's getting there.
It was clicked a long time ago.
I know. It's on battery too, so it's probably on some kind of a funky
low
save
power
thing.
mode.
So the idea, my thought is at the moment, because I want to duplicate this onto multiple machines, on multiple copies of it, as you can see, because I've got 2 or 3 boards here, is to go with an SHT 41, a 31, a BMP 280, and the AHT10, I think is the name of the chip that does the air pressure. And then I can duplicate that across all the versions.
Okay.
On individual modules, but if I go for a multiplexer, I can then put 2 onto 1, can't I? I could put 2 identical setups onto different buses.
Yes, that's right.
Is that right?
Yes. You can also do things like, because you're using a multiplexer, it doesn't mean you can't have multiple devices on each of the multiplexer legs. So you could have a temperature sensor and a fan device on one leg of the multiplexer, and then a different temperature sensor and fan device on another leg. So you, I think that'll give you the best flexibility.
Will that work? So just looking for the the maximum flexibility.
Yeah, Wagon Load says if they can't be changed, you need a multiplexer. Yes, that's right. You need some way of being able to select which device you want to talk to.
TDA.
Yes. What is it? I'll need to look it up. It's in the. I can't remember the part number for that. I used it on the Testomatic chassis, so I can get it out of. In fact, what I'll do is while you are looking at that, right now Gavin is just.
I think the GPS is holding everything up.
GPS is stopping it.
It's just
okay.
It's a showstopper.
Yeah. I am just going to look up the Testomatic design and find the part number.
Something happened. Got somewhere. We're one step further.
How about I switch that back to your desktop? So it's now sharing your desktop, and you can click around in there and show what's going on. Oh, we don't have any data coming yet from supply air out.
Yeah, it takes a while. It is behaving really slowly on my laptop, and it normally behaves better. So I'll try and get some. I'll hit the psychometric button, the one we saw last time, and apparently a new device has joined my network called Raspberry Pi. Okay.
Okay.
Yeah.
What Raspberry Pi device
I don't
is that?
know, something, somewhere. I don't have one
Are
plugged
you
in.
connected to the correct network is the question. Oh, you must be, because you've got the device.
I'm on
coming up
timetable.
there.
Somebody else has jumped on my machine from somewhere. Oh, that's all right. It's 20 gig on that one or something. They can. There we go. What do you got? Expressive, isn't there? Wasn't on my network earlier, but is now. Oh, it keeps. Yeah.
I'm just looking for the.
Oh, there we go. Getting some data. Cool.
Oh, good.
Getting some data. So now we might actually. Yeah.
Oh, okay, here we go. This is the ID. I'm just going to briefly jump back to this view. So this is the TCA 9548A multiplexer. That's the one that's being used on Testomatic. So yeah, that'd be a good one to use.
9548. So you've got one into.
So this side is the
7,
SDA. There are 8.
8.
I'm only using 7, so it's from 0 to 7. So there is the SDA and SCL, which goes to the upstream microcontroller, and then you've got 8 sets of I2C coming out of it. So I think that would be a good one to use. So let's jump back to here. Oh, have you reached? There we go.
Yep, so the psychometric chart bit is playing up probably. So yeah, this software I haven't fully tested in the last couple of days. However, it does, just to show you, it does list all of the devices on the I2C bus. So we can see here now what hardware is present. And I can rescan, I can console, I can look at the anemometer probe, and then if my network is up and running properly, I would get a network detail in there. And we're just waiting for these sensors to come up. So this one here is retrying sensor A, which is...
That one was coming up as supply air out previously.
Hang on, yeah. And it turns. So we're trying very hard to get it to work. So I've got, yep.
Maybe you got something coming through.
Sometimes I end up with two devices on the bus at the same time, and that really does confuse things with the same setting. I'm just making sure I don't have that situation at the moment. No, I think I've only got one.
They're all unique.
Yeah. There's nothing on that, so I might unplug that one.
Sorry, folks, you can't see what's going on.
No, that's one I can't plug in, and there's one I can plug in, and there's adapters. So what dropped out there? Nothing?
Oh, this just appeared.
Yep.
Okay.
Yeah. So GPS
So on the left.
data started and stopped, so check my power connector. So I need to improve my wiring on that maybe, I don't know. And then the INA chip, which is this guy here, which was my other question for you, John. Yep. And I wanted to know, John, if I put an this is what I did last night just to see whether this would work or not. If I put now it should be able to detect this INA 1126 power.
Okay, so that's device hex 40, which is currently showing in red.
Yeah, and it should... Can I do a rescan and find it?
Give it a shot.
GPS has got
Scanning.
something. Stalled. It's got some accuracy. It's an old reading, very old one. And no fix. Could be it's... Well, no, I don't know. I'll have to get to the bottom of that.
It could just be, as was suggested.
The tin roof, do it?
Yes, exactly.
Could be, yeah.
But that I2C scan should be giving us something now.
Yeah, everything's really slow though because things have disappeared. So if it detects that correctly, which I'm sure I've wired it in the right way. Hang in there. Yeah, that's right. It's very slow performing at the moment on this laptop anyway. So can the guys, I will wait for that to finish, or we're watching that, are we? Yep.
Yeah.
So what happens is also, so last night's very last change was to add on this indoor sensor is still, we've got two sensors, which is good. We've got a reading, we've got values on the LCD flipping around, or the OLED, isn't it? Yeah, it's a fancy word for it. And if it's finding that, there's now, because I needed it, under, I think it's psychometric, there's a power. So I've got a voltmeter as there, there, coming off the INA 226.
Okay.
And my thought was, if I'm going to run it on a battery source, and I was talking about running it on solar or charging some other array, could I put that in series with my power supply and then monitor the battery condition as it's going up and down with the charging of the solar?
Should be able to.
Should be able to do that?
Yes.
Are they an isolated?
That
was the bit I wasn't sure about.
Recall. I think they generally are. Usually it's a pass-through, so they're often used for high-side sensing.
I'll do a refresh.
But with a ground reference.
Not today, Gavin, is probably the message. I can assure you this worked before my last iteration with Mr. Claude. And then that was last night and this morning, being able to run just a light bulb, which I could then do volts, amps, watts, and things on it as well. So I should be able to monitor the power consumption. If that was plugged into there on 12 volts, running it off on battery, I will try this at a later point. Other guys don't know what we're doing because they're not seeing
No,
it.
they can't see that.
Sorry, fellas, ladies, everybody. Yeah, just
I'll drop back to that view.
yeah. So my last thought was to add, in case you're wondering, guys, INA226 is a current voltage sensor. Does power calculation, volts, amps, watts. It's I2C device. And as I was just saying to John, sorry about that, about the blank screen. Nobody loves those. Was I've got a battery here, 12 volt one, which I'm running things on, just an alarm battery. That sensor is the one we're trying to do the I2C scan on. And then I was thinking if I plug that into here, into my 12 volt power source here, then I should be able to detect the power being drawn through the circuit.
Yes, it should be able to monitor itself.
The electronics and monitor itself. And then it does display that on that screen when it finds it. So the scanning is not taking place. Maybe a reboot might, one quick reboot. Might pick everything up with a bit of luck. It'll do a scan on restart, won't it?
I don't know. I guess so.
Well, it does typically. It does typically, and then it comes up and tells you what the voltage and the current is and all that sort of stuff. Which is where probably, yeah, don't know. GPS could be hanging that up. I need to have a look at that as well. All right, recap. What do you think? Progress?
Oh, yeah. Yeah.
Any headway?
There is way more on this than last
Scary?
time.
Scary?
I think you've got all of the components. Now you just need to expand it to multiple sensor devices.
Yeah.
So you've shown that you can read from all of the sensors. You can read from the fan to
Yep.
detect airflow. And I think with the addition of something like a multiplexer in the middle, so that you can plug in a whole lot of different devices in parallel, it should give you what you need. That is, so is that booted?
So yeah, we're getting there. It's booted. It's IP unset, so it's lost access to something. Device is warming up again, so we're in the same situation again. Do you think I should get a bigger screen? That was my other question. I've got old eyes like yours and glasses on. Students have got really good eyes; they can see stuff. And I thought, is it worthwhile mounting that on here as a third I2C device mounted onto the housing itself, so I can see it remotely without having to go back and look onto a web interface?
Yeah, but you would only do that on one of the fans. Presumably you'll end up with 3 fans
One.
for this installation, one with the display on it.
Which way faces towards you? The return one, that's coming back into the room with the pre-chilled air on it, would be a good way to go. All right, so yeah, IP unset means it's gone back into captive portal mode.
Yeah, so
it's lost sight
hasn't
of the
connected to the
NO means
AP.
that we've got no GPS, but we've got sensor data, which is good. And what would be a good screen to go? What do you say? Get ESP to use the fan as a power generator. Well, I like it. I do like your
It's an
idea.
interesting idea. You'd need a fair bit of wind for a while.
Well, the other side of that was if I'm, like I said earlier on, going to use the. Oh, okay, let me go into this one more stage, John. I know we're going to head off shortly. Very shortly. One of our units is about air conditioning. One of our units is about voltage and power and that. So that's another subject we cover. So by having a second power item inside the system, we've got another module covered. And then we've got another one about sustainability the guys use. And hence the, would this work with a impeller and water? So we have a project where they have to also measure over 2 minutes how long does it take to move 20 metres of water from 2 metres up down to ground level. And this should be able to just pass through there at a pressure. This is a Hall effect device, by the way, guys. Plug that into one of those boards. This would probably be my next revision of the board, would be to do that. add that as a device somewhere else, and then I could do that experiment for the class at the same time. Which, if you're in a caravan or something, you can put something like this into a caravan. So
Yes.
when you turn the pump on, it'll tell you how many
Yeah, keep track of how much water
you're
used.
consuming, or whether it's running and it's you've got a leak in your pipe, type thing. So was the thought. All of which are exciting. All right, I don't know. I do know, but I've got so many things going on where I want to go with it, and I don't know. Would anyone else find this useful? Would probably be the question for anyone who writes in the would anyone in the chat have a use for something like this?
Okay, well, a related question is, for people who are interested in this, where can they find out more about it? Do you have anything on GitHub, anything public anywhere?
I don't normally put stuff on GitHub. I'm like that because at the moment, I'm not paranoid. It's not a doxing thing either. It's just a case of I just don't, being from a security background, I don't like to share too much until I'm sure it's right. It makes sense. But I can give you the code and we can put it somewhere on the Superhouse if you wish to, or if you're okay with it.
Well, would you, I guess the place to talk about it is in Discord,
Yep.
if people are interested in that.
Yeah.
So they can ping you in Discord?
Yep.
Okay.
Ping me in Discord. And we can probably set up a topic in Discord and
Yep.
take it from there.
Cool.
Right, okay. I'm
Okay.
sorry about the failure on the web page. I'm sorry about the failure on
No,
the
it
GPS.
wasn't. We saw it working.
It
So,
does function.
Yeah. It was only after we tried to change the wireless network over to the lab and then switch it back that things started
Yeah,
changing.
and I expected that might have been the problem anyway. So,
Yeah.
well, I hope anyone's. Thank you, John, for inviting me.
No worries.
Actually, I
Thanks,
invited
Gavin.
myself, didn't I? I just wanted to help you do a catch up, and I figured this was a short one. And thanks for everyone for watching. It's been really good so far.
Yeah. So, everybody, thank you for coming along.
We've enjoyed your company. I hope you've enjoyed ours.
We're still a few weeks away, but just as a reminder, there is a barbecue coming up sometime early September, so make sure you check that out. And so everybody, thank you for coming along,
Have a great week.
and make sure you build something awesome, and we will talk to you later. See ya.
See you now.